Okay, so we're going to be continuing today with doing motion in terms of parametric equations. So obviously now it's not one directional motion. Something is moving with both a horizontal and a vertical motion. Okay, so let's take a look at what they give us here. Obviously, you know that the AP exam likes to vary the way that they present to you information. This is definitely a calculator question, so some of this will be done in the calculator, but interestingly enough, some of this will also be done off of this graph. So important things to point out, they give us x prime of t, or dx dt. They're also giving us the initial location of this particle, okay? So that means that at x of 0, okay, t equals 0, x is located at 5, and at t equals 0, y is located at 1. Okay, in terms of y, they don't give us an actual like y prime of t or y of t to take the derivative of. They give us the graph of y here. Okay, and what that means, if I need any y like of 1 or y of 2 or y of 3, I can get those values right off of this graph. And if I need any y prime values, that's the slope of this graph. Okay, so other things that you might want to point out, if you need to find out, let's say, the x coordinate at a specific time or the y coordinate at a specific time, you're going to have to set up an initial value question. So if I want to know what x is at some specific t, I have to take whatever initial location I'm given that particle is located at. So in this case, x of 0 equals 5. And I have to add to it the integral from when I knew that initial point to when I want the final location. And remember, you're integrating technically like the velocity to get back to, your position. In this case, I'm going to look at it as x prime of t because that's like the velocity specifically in the horizontal direction. Okay, so again, follows a similar model to stuff that you guys did last year with motion, but obviously now it's in terms of like, two different coordinates. If I had to do this for y, I would do the same idea. The initial location, I know my y value, plus the integral from when I know that initial to when I want the final, and it would be y prime of t dt. Okay, but again, in this case, I probably don't have to use that because I have the graph of y, so I can get all my y values off this graph. So, first part is that we are looking to find the position of the particle at t equals 3. Okay, so basically you're looking for something like the position vector at this particular location. Okay, and so what that's going to come down to is knowing what is the value of x of 3 and what is the value of y of 3. Okay, so x of 3. For me to figure out x of 3, I have to use what I had mentioned above. The initial location, okay, plus the integral of the derivative of x. Okay, so that's going to end up telling me where I started plus how much my position changed by. Okay, so when I go down here, my initial location is x of 0. Okay, I'm going to integrate then from 0, which is where I'm starting, to 3, because that's where I want to end up at. And what am I integrating? X prime of t dt. As I mentioned earlier, this is definitely a calculator question, so this is something you'd type in your calculator. To be a little more specific, x of 0 is 5. Integral from 0 to 3 of x prime. You can just put that right in your calculator if you want to put that in as y1 or y2 or whatever, and obviously round to 3 decimal places. That comes out to be 14.377. So I know that the x coordinate the x value of the vector that represents the position of the particle at t equals 3 is 14.377. As I mentioned earlier, if I didn't have a function for just y, I'd have to actually go do this initial value type problem again. But if you remember, we also have the graph of y here. So to get y of 3, just go to when x equals 3, t equals 3, your y value is -0.5. So that's the y component of that vector. So your answer for that first part would be 14.377, comma, -1/2. Okay, part B. Find the slope of the line tangent to the path of the particle at t equals 3. So just like we've done in the past, slope of the line tangent, that would be normally dy dx. In terms of parametric equations, that means you're doing dy dt over dx dt. And you're specifically doing that in this problem. So I'm going to write that down, dy dt over dx dt. And you're specifically doing that here at t equals 3. Okay? So in other words, you need y prime of 3 over x prime of 3. So let's start with y prime of 3. As I mentioned above, you have the graph of y. So a y prime of t value is going to come from the slope. What is the slope when t equals 3? Well, if you count your y's over your 1, up 1 over 2, you have a slope of 1/2. So y prime of 3 is 1/2. X prime of 3, you have x prime of t given to you. So you just have to plug 3 into this equation. Honestly, you could actually leave your answer as this, 3 squared plus sine of 27, because remember, you don't actually have to simplify. Okay, so moving on to part C. So part C says find the speed of the particle at t equals 3. Well, similar to the way that you guys did speed before, you're taking like the absolute value of the velocity, only this time you're actually calculating like the magnitude of the velocity vector at t equals 3. Okay, so how do we do that? That means you're going to take the square root of x prime squared plus y prime squared, and specifically you're going to do that in this case at t equals 3. So again, this is not something you'd have to do by hand. This is something you definitely want to plug into your calculator. You can honestly plug this in and then go right to what your answer is. But if you want to see a little more specifically, this would be something like 3 squared plus the sine of 27, like from the previous part of the problem, plus 1/2 squared. And that's it. And when you do that calculation, actually, technically, you could leave it just like this. You don't even have to actually plug it in your calculator. Nowhere does it say you have to simplify or round. If you do decide to make it a decimal number, then you have to make sure you round to 3 decimal places. But again, unsimplified answers are perfectly acceptable. Okay, now for the last question, you're calculating the total distance traveled by the particle from 0 to 2. So if you remember, for distance, that's going to come now from integrating that speed, if you will. So integral from a to b of the square root of x prime of t squared plus y prime of t squared dt. So what's interesting in this question is if you notice that we're working on the interval from 0 to 2. As I mentioned before, you have a function for x prime, but you don't have a function for y prime, so you're going to have to use the values off of this graph we have right here. But you'll notice that there is one slope as you go from 0 to 1 and a separate slope as you go from 1 to 2. So you're going to have to break this up into 2 integrals, something that goes from 0 to 1 and something that goes from 1 to 2. You can see the slope initially is -2, and then eventually the slope comes out to be 0. So when I set this up, this is going to come out to be the integral from 0 to 1 of the square root of x prime of t squared plus y prime of t from 0 to 1, again, is the slope of the graph from 0 to 1 was -2. So -2 squared dt. Okay, you'll plug that in your calculator. If you want to try to probably plug it in all in one step, I would probably suggest that so you don't make mistakes. You'll now have to have a second integral for the second part of the distance traveled. Again, because of the fact that y prime of t in this case is now 0. Again, go back to the graph if you need to see. You do actually have to get a value for this. Again, unlike the previous one where you can just show what you're plugging in, this is a function of t when you plug it in your calculator. So you have to plug this in, round to at least 3 decimal places. Obviously, you can always go more, and you'll find out that the total distance traveled by the particle in this case is 4.350. There are no units, so you don't have to put units, but obviously if a question